Okay, it's coding time once again, folks, and I'm back with a Codewars exercise, and this is speed control, a Java exercise. Doing it real big with Java today, baby. All right. Description. John's car, in John's car, the GPS records every s seconds the distance traveled from an origin. Distances are measured in an arbitrary but consistent unit. For example, below is part of our record with s equals 15. I guess s is seconds. What you got here is an array of really double values in Java. And these are distances traveled from an origin, so they get bigger as you go forward in the travel. So jumping up. So what you can take away here is an increasing set of float values in an array. And the sections are, and here it's showing the getting the differences between the distances. So just the difference between 0 and 0.19, 0.5, 19, 0.75, and 5. You see, these are differences. And it kind of clues you into the idea that you're going to need to get differences. But there's more to the story. We can calculate John's average hourly speed on every section, and we get this list of, or this array of doubles. Where, yeah, these are average hourly speeds based on these differences and based on some other factors that are that I'm about to get to. So we got an array of average hourly speeds. So given s and x, not e, given s and x, the task is to return an integer, the floor of the maximum average speed per hour obtained on the sections of x. If x is less than or equal to 1, return 0 since the car did not move. So yeah, there's your little qualifier. If the length of your array is less than or equal to 1, return 0 because there's no movement. There's no difference in speeds, or no, there's no difference in distance. That's the thing. No difference in distance. So we have to get the maximum average speed per hour. This is a list of the average speeds per hour according to these different differences in the distances. You're still with me? Yeah, I was a little confused on this one too. These are the average hourly speeds given the differences in the distances. And then the question is, how do you get these? The objective is to get the maximum of these. You see, the maximum. And of course, the maximum is 74.4. And so you return 74. But yeah, how do you get these? That's not really given. And maybe you're thinking, I've got to come up with a formula myself. Maybe I'll look it up or whatever. But actually, lower in the instructions, they give you the formula. It's down here. So here's the formula. It's 3,600 times delta distance. Now, what is delta distance? Delta distance is one of these. So each difference is going to be used as the delta distance, and then you divide by s. S is going to be given as an argument or as a parameter, or it's going to be given as an argument. It's stated as a parameter. But anyway, s is going to be given. So we've got all the pieces for this formula. Got to do 3,600 times the difference. How do you say that? The difference in distance, which is one of these, divided by s. And s is given. For instance, in this example, s is going to be 15. All right, so having said all of that, we get a list of, or an array of them, array of these differences, and then we find the maximum, which here is 74.4. We got to convert it to an integer, as is said, convert to an integer, and then return it. So that is the task, folks. Okay, I say folks this morning. Screwing up all the words. But yeah, that's what I got to do. And you'll have to do it yourself eventually. Don't copy my stuff. Don't buy my style, homie. Actually, you can buy it all you want. Just don't chew. Okay. I think I'll increase the size. Yeah, I'll increase the size a little bit. Alrighty. So I'm going to do a sort of a qualifier right off the bat just to make sure we're good. I am going to say if the length of the list, or I keep saying list because I'm doing a hell of a lot of Python stuff. If the length of the array is less than or equal to 1, we're going to return 0, because if you have an array that only has one distance in it, it didn't go anywhere. There's no difference. Right, folks? All right. I'm going to create some arrays here. I'm going to create one array. Oops, -1. This first array is going to be to hold the differences in distance. Another array is going to be used to hold the averages. And I'm using x.length -1 for the size because I see that when you do the differences and get the subtractions, the number of them is going to be one less than the total size of the array. Because yeah, if you subtract each set of values, you're going to end up with one less as a result when you do all the subtractions. Same thing with the averages, because the averages are just going to be averaged from the differences. Or actually, yeah, you're going to use each difference to get the average. So the number of averages is going to be the same as the deltas, so to speak, and that's why these are the same. So let's stop rambling and get into the loop, where I'm going to loop through this array of distances, and I'm going to get the differences and the averages. So I'm going to do a lot in this array. Let's move forward here. Yeah, I'm going to get the deltas, I think. And actually, yeah, kind of revising my earlier code, but I don't need one of these arrays, but you'll see as I get this done. This is the formula that was given at the bottom of the exercise instructions. We'll divide by s. That's good. Okay. Yeah, I'm not going to need this delta times because I'm not doing kind of any intermediate storage. I'm doing the difference in here, and I'm not pulling it from any kind of storage, so I don't need that array. That was from an earlier version that I did. Anyway, I'm using the formula given to get each average distance. I'm using this is the difference in distance right here, times 3600 divided by s. Just like if we go here, just like this formula, that's what it is. So let me expand it back out, and we got that. And once I have a set of averages, an array of averages, we're supposed to get the maximum. Well, yeah, there's a few ways to get the maximum number out of a set of numbers or an array of numbers. I'm going to use the arrays sort method, because if you sort an array in ascending order, the last element is going to be the highest. It's a very easy way to do it. Maybe a lot of labor, but oh well. It's not manual labor. So I'm going to do sort on this array. to get the max. And the max is going to be, again, the last element of that list. And I got to import Java util. I was import the whole thing. Wasteful, but it don't matter. All right, now I'm just left with the return. So I got to get the maximum out of that array of averages. Then I've got to convert it to an integer. That's the last step that it said. Get the floor of it. So if you convert from double to an integer in Java, I believe it gives you the floor. So it works. I don't believe it, I know it. I gotta have conviction, right? And that is that. Now I can just check this and see if it will go, because it looks pretty good. So let's try it out. Test. Nope, got errors. What do we got here? Let me check this out. Yeah, so it would appear the issue was that I did not have new in front of double. So let's try this again. That was not it. You look here and yep, there's always possibility of mistakes, of course. You gotta stay humble in these situations, and that passes the test. And run it through, it's a little slow, but it passes, and that is great. So we have another successful run, and that, my friends, is speed control done in Java this time, and this is a Codewars exercise. There's the code. That's what you got. This is me, and that is you, and I am out.